code for a real-world example. Pun intended, because this is the real-world SPA example. All right. So for an example of and then, I want to look at our ISO 8601. So we mentioned previously that we have this notion of ISO 8601 encoded dates. This is in the previous section. We talked about this. So this is a string format, and we have a library called Elm ISO 8601, which converts from those date strings to the POSIX timestamp, which is what we actually want to store in our model. Okay. So right here we have a little helper function that decodes it, because we want to expose an ISO 8601 decoder. The way that it works is it is a two-step process. First we say decode.string, because we know it's going to be a string coming from the server. And then we pipe that to decode.andThen, a function named fromString, which is our little helper here. FromString takes the ISO 8601 string, which we've successfully decoded, but at this point all we know is it's some sort of string. We don't actually know if it's got a date in there. If it's got a date, we don't know if it's malformed. We don't know anything about it other than that it is a string. So then we call ISO 8601.toTime, which takes a string and returns a result. So in the OK branch of that result, we've got a success value, which is a time.posix. And in the error case, we have a fail, which is to say that something didn't work out about the date. Now here we're calling decode.succeed on the success branch with the successful value, which is to say the POSIX timestamp. And in the error branch, we're just sort of disregarding whatever failure string that it gave us because we don't really care. And we're just saying, yeah, that was an invalid date of some sort. So we're failing decoding. So this is an example of our using decode.andThen as a way to turn a successful string decoding into a potential overall decoding failure, because this decoder's job is not just to give us a string, but to give us an actual POSIX timestamp. Now, in some cases, we might be doing additional validation that's sort of optional, in the sense that that validation might be like on top of what we're normally doing. We want to check that a string is not empty, something like that. In this case, we don't really have a choice. I mean, how can we possibly give it a valid time.posix value from a string without handling both of these possibilities? Right? ISO 8601.toTime gives us back a result. So if we didn't want to use decode.andThen, I mean, how would we possibly map that to a successful value? We need in some way to handle this error case. And if we weren't using decode.andThen, we'd be forced to succeed and say something like, I don't know, assume it's the epoch, which would be much worse than failing the decoding, which is a much more accurate representation of what's going on here. So we can see in this simple example on the screen sort of the power of decode.andThen. Not only could we, from here, say success, we could actually do this again if we wanted to. We could pipe this right here, because this is a decoder, to decode.andThen and just keep going. We can create an entire branching conditional system of decoders that checks one after the other and makes sure that all of them pass, every single one of them, those additional validations that we want to perform, before ultimately resolving to this one decoder. And all of that logic is going to be wrapped up inside that one decoder value, and anybody who's using it doesn't necessarily need to know all the hoops it's jumping through to make sure this data is actually okay. We can also note that it's entirely possible that we could implement decode.map in terms of decode.andThen. It essentially has the same semantics, except that you always succeed. So if we wanted to, yeah, that would be no problem. If we ever use a library that implements something like andThen with those same semantics, and we're like, I really wish this library gave me map, but it doesn't. Well, the good news is you can implement it yourself. andThen is so powerful that it's actually capable of implementing map in terms of itself.